So today we're looking at the place value blocks, how our numbers are represented. They can also be known as base 10 blocks and multi-base arithmetic blocks, and you might see them as Dean's blocks. First of all, we have to teach the children what they represent and what they're called. So that is known as a cube, and in this instance it's representing one whole number, but it doesn't have to. This one is a rod, and on this baseboard it's representing 10 of these ones. This is known as a flat, and it is representing, if you look at each tiny bit, 100 of those or 10 of those. And then you'll notice I put a comma, and you'll see why as this goes along. This next column, the thousands, is represented by this cube. So actually the first thing that you'll notice is there's a pattern emerging here already. It goes cube, rod, flat. My comma comes in, and then we start again with a cube. The next column would be tens of thousands. That means we'd have 10 of these. And what you need to do is compare what that would look like against that rod. So imagine that each of those cubes is now that size, and you've got 10 in a line. That's how it would look if you're in the 10,000s column. And then the next column along, and this is where it gets a little bit more abstract. So you're kind of showing them with these representations, but you wouldn't have enough equipment to actually be able to make this. You would then have, imagine, 10 rods made of these size cubes fitted together to make a flat this size, where each cube was this size. So the children have got to imagine it, so they can imagine what happens. So you can see the pattern goes cube, rod, flat, cube, rod, flat. And then when you're back to the millions, you're going to have a massive cube again. Your tens of millions will be a rod of 10 of those cubes, and your hundreds of millions will be another a flat made up of those. So it's very difficult for children to imagine that kind of number. So when you get up to this level in place value, they have to have understood the patterns of how the numbers work together. So that's the first thing they need to understand. And then they do need to understand that this rod represents 10 of these ones, and that this flat represents 10 of these, and that this cube represents 10, and that each column it's got 10 times bigger. And they need to do a lot of work around playing with numbers to really grasp that. And where children often get stuck in maths is they don't understand that. And then we don't make links when we're adding, subtracting, doing fractions and decimals back to this basic principle, because if we did, a lot of the misconceptions that our children get would be cleared up. And obviously going the other way, if you work this way down the place value system, your numbers are getting 10 times smaller. So you really need to drive that point home at this time. So you could do a lot of pattern work. So obviously you can only represent up to 1,000 because that's the only piece of equipment that we had, unless you have an awful lot of it. But what you then can do is a lot of work based around the columns. So just looking at the top row here, if you've got older children up to year 6, they would need to understand the names of the columns. The reasons I've put the commas there is because at each point after the comma, they need to imagine that there's a new cube starting. And then you get a rod of 10 of those cubes, and then you get a flat of 10 of those rods. So that's how the pattern goes. And it's the same way if you go into decimals. Now, I've seen decimal columns called all sorts of things, like with little letters and so on. But actually, it's much better to call the decimal columns by their fraction name, because then it's very easy to make a link between a decimal fraction such as 0.6 to being equivalent to 6/10. They will immediately get that link, and it makes it much easier to relate numbers to percentages and so on. So I've always taught my children to write those columns in the fractions, and it just makes it a whole lot easier. So that's how we would start. After that, the next thing that we've got to do is get the children to understand how our numbers are written and how they would look. And this is going to seem really basic, but even if I were to go and work with a year 6 child, I would go back to this to make sure they understand it. And it's amazing how many of them don't understand this particular principle, which I'm just going to show you. So if I put my columns on here, and I'll call those ones, tens, hundreds, thousands. All I want them to understand is how the number system works. So I'm going to say, I want you to represent this number. So I'll write it in my ones column, and they will happily do that. And I will go all the way down to 9, and I'm going to teach them to put it in the Numicon array and expect them to count in 2s. So I'm going to put that principle in early. So imagine we've done that all the way down to 9. So now they're going to represent 9. So 2, 4, 6. And I really will take my time over this, and I really will do every single number that's represented in that column. So 2, 4, 6, 8. Here's 9. And then if you say to them, right, I want you to make 10, they will immediately do this and put that on. And then if I say, does that look okay? They will say, yeah. But then you have to explain that each column, usually when we're writing it, can only have 1 digit in it. And 10 has got 2 digits. So what shall we do? And this is when you're going to see their understanding, or lack of it. So you have to explain, you can't have 10 in terms of ones. It has to be written like this. And the way we would represent that is that we take those out of there and put that in there like that. And because there are no ones, we have to put a place value holder in. That is often a total revelation, even to older children. And once they've got that, then you're off. Because then you can carry on. So you can make 11, and you can demonstrate how you would represent that by having 1, 10 and 1, 11, because they recognise that. But often what they don't understand is what that's been represented by. So in that way, you would then practice doing making and writing lots and lots of 2-digit numbers. So you can do practice by making a number or asking the children to make a number. And I would always get them to start counting in 2s. So if you've got numbers like this, I say to them, take 2s and move them so that you know you've counted them. So this would be 20, 40. That's obviously after checking that they can count in 10s. And then we put them in a Numicon array, and we would teach them to count in 2s. 2 and 1 more is 3. That also helps them to see whether it's an odd or an even number, because they can see it. And so you might ask them to make a number, and then you might say, write the number. So what they're doing is they're getting a real clear link between what they see and what they write. So at school, they've probably had lots of practice at doing this sort of thing, but not enough early practice at doing this, and they don't make the link, and then they get into all sorts of difficulties.